Okay, hi. These are the videos a little bit long time coming on conditional probability. Um, should be a few of them. They will be shorter than the class notes, so you should look at the class notes, I think. I'm questioning whether I even need to do the videos anymore, but let's do some without as many examples and keep going for now. So, conditional probability, the general idea is I have partial information about an experiment and I want to recompute or reset the probabilities of other events um, based on that partial information. So we better stay safe and stick to our dice, which seem to work pretty well with a lot of things. Roll 2 dice. There's the picture of the sample space with the 36 equally likely outcomes, and there's the shaded in squares are the doubles. So we'll let D be doubles, and we know the probability of D is 1/6. There's 6 out of the 36 outcomes that are doubles, and they're equally likely, so it's 6 out of 36 is the probability of D. Now, suppose we're told in addition to that, that in addition to rolling 2 dice and that the dice are fair and everything, is that we know the sum is less than or equal to 5. I don't know how we know that, but we know that, say. And we want to recompute the probability of doubles. Okay, so this is already written here, and we want under this condition to recompute the probability of D. Well, first thing is we probably need a new notation. If we just write all these words down in P of D, it's not, how are we going to differentiate it from the other, the statement right above? So the way this is usually done is the event that we're conditioning on, we'll label that, or we could just write it in English. But we'll label it here, and then we have a new notation. So we'll let E equal the sum is less than or equal to 5, okay? And then we will specify this using a vertical bar. Then probability of D given E is called the probability of D given E. And it is what it should be. Since we have equally likely outcomes, we could say P D given E is just equal to the number of doubles that are in E, so I have to take the intersection there, over the size of E. So this is because we have equally likely outcomes. So in other words, we reset S to E and only consider the doubles that are in E, right? Because everything's got to be in S. So in a way, I could look at this, and I encourage you to do this. I look at all the ways I can get 5. So let's see, there should be 4 here, and 3 here, 2 here, and 1 here. Right, this is E. And where's D now? D is just, there's only 2 ways I can get doubles, right? So this is D. If this was D and S, this should be what in E? This is DE in E, right? 1, 1, and 2, 2. So P of D given E, probability it's doubles if I know the sum is less than or equal to 5, is 2 out of 10, right? Okay, 1/5. So it went up. Okay, actually, if you know the sum is less than or equal to 5, it goes up. Uh-huh. Okay. Let's see. What about, let's just for practice, I said I wouldn't do a lot of examples. Well, we have it written in the notes too, but maybe just for an example, suppose let's let f be sum is, say, greater than or equal to, let's just see what we get, greater than or equal to, I don't know, let's pick something, 10, and find what's the probability of, let's say, what's the probability of f given doubles? Let's flip it around. So this should be fd, because these are ELO, over d. Okay, so here is my d, right? It's just the diagonal ones. And if f is greater than or equal to 10, then I could get 2 5s or 2 6s. So this is equal to 2 over 6. This is 1/3. Okay, if I got doubles, the probability the sum is greater than or equal to 10 is 1/3. This is not the same as the probability of f. It's changed, right? Probability of just regular f before, just like they weren't the same before. The probability here, if we go look, probability of d was 1/6. Probability of d given E is 1/5. It went up, and this thing can go up or down or stay the same. Here, the probability of f is 1/3. Given d is 1/3, but the probability of f not given d is just the sum is greater than 10. So we could just write this as a matter of interest, whereas what is, I'm not even going to make a picture, probability of f is equal to greater than or 10. Let's see, 3 ways to be 10, 2 ways, so 6, so 1/6. Not the same, okay, goes up a lot, doubles. All right, very good, very good, very good. Okay, so that's, this is a way to do it when we have equally likely outcomes. What if we don't have equally likely outcomes? Well, another way I could have wrote this is since probability of, say, E given F, let's just pick now just in general, is equal to EF over F for events EF and S, we have PE given F equals EF. I can just multiply by 1. I do it this way. So when they're equally likely, so we have this is ELO. And this can also be written as you know, for ELO. So this is ELO, this is ELO. This is the probability of EF over the probability of F. Okay, and in fact, even when we don't have ELO, we will take this to be the definition. It does make sense. So always, so we'll write this down, always ELO, equally likely outcomes or not, our definition will be PE given F is equal to PEF. Okay. All right. All right, that's getting there. So let's do one example where the outcomes are not equally likely, and then we will stop and So example, suppose my keys are at work with probability. See, I don't know where my keys are a lot. With probability equal to 1/4. They're at home with probability equal to, let's see, I don't want to do too many of these. Let's say equal to, why did I pick that? Let's say 1/5. And in the car, with probability, let's see, equal to, let's see, 0.55. So I think those add up to 1. If not, I made a mistake. Yeah, they do. Okay, so so I check car and keys are not there. What's probability? They are home. I don't want to write it like that. I want to write what's P just in English because it's under this condition. Well, the way to do this is, let's set it up. We want, so we want probability they're home given they're not in the car. Sorry. Okay. Now let's use the definition. This is PHCC. Now, what's the probability? What can I say about the event home intersect with not in the car? Well, that's just the home is a subset of this. So this is just PH over PCC. PCC is 9 over 20, so I have 9 over 20, and probability they're at home is 4 over 20, so it's 4/9. Okay, I gotta stop. You could tell I was rushing there at the end. Again, see the notes and review, and stay tuned for the next one.